Davkis here, and welcome back to Davkis Builds. In the last episode, we went through and got all of the LEDs connected into our Arduino circuit, and then did a test to make sure the LEDs are going to work the way we want them to. So now that that's done, it's time to turn on the transmitter and receiver and see what kind of data we can get back from it. Before we do that though, I want to go over how radio-controlled receivers and transmitters work as far as communication. Most RC receivers and transmitters use a concept called pulse position modulation. This is very similar to pulse width modulation, except rather than having the entire pulse be high for a specific amount of time, we actually will do a very short high pulse and then have low for a certain amount of time, and then another short high pulse. And the analog value is what the time frame is in the middle, generally from about 1 to 2 microseconds. Because pulse position modulation is an analog signal, we can actually take the data from multiple channels and stack them on top of each other into a single analog signal that can run across one channel. The downside to this is it then has to be decoded into the separate channels on the receiving side. A newer version of this is called pulse code modulation. It's the same thing as pulse position modulation, except that instead of an analog value, it's encoded into a digital signal. This digital signal is then output across the individual channel data lines. This actually helps to reduce the amount of interference that the analog signal would sometimes get using just pulse position modulation. Most receivers using pulse code modulation, when they receive an error, it will actually hold the previous value that it received until it gets a new complete data packet. Okay, now that that's out of the way, let's take a look at how we're going to map the channels from the transmitter, and then take a look at the code we're going to use.
Now here we see a picture of the flight controller and how all of the controls will be mapped. On the right stick, we have channels 1 and 2, with channel 1 being the horizontal and channel 2 being the vertical. On the left stick, we have channel 3 and channel 4, with channel 3 being the vertical and channel 4 being the horizontal. Channels 5 and 6 will be the two knobs at the top. Now here is the program that I will be using that will take the pulse length value read in from each channel on the receiver and write it in numerical form to the serial connection and back to the PC so that I can view it. Now what this program does is, first off, I have an array set up with all of the input pins that the receiver channels are connected to on the Arduino. This array is just a storage for the input values as I receive them. Each position here matches the position for the pin, so the input value for channel 1 will go in this spot, channel 2 will go in this spot, etc. The setup function will initialize the serial connection and then set up each of the pins as inputs so that I can actually read values from them. The loop function will loop through each channel, in this case going from 0 to 5, since that's how the array is addressed. And for each channel, it will read in the value using this read channel method I've created, and then write out that value that it gets back to the serial connection. The read channel method, its only purpose is to read in the value from each channel using this pulse in method. This method will decode the pulse code modulation value from the receiver into a numeric form and then drop it into its respective position in the input array. The serial input write method will take in the position, the channel that we're currently reading from, and it will write that channel out to the serial, adding 1 to it since the array is actually 0 based, so it'll be 0 through 5 to represent channels 1 through 6. And then write out the input value that we read in from the receiver. And this will repeat for each channel, so it will actually repeat across the page for each channel, and then once we get all 6 channels, we hit this serial print line here, which will drop down to the next line, and then we read in all 6 again. This will happen thousands of times a second, and so we will actually see it constantly changing, so we can actually see as we change things that those numbers will move. One note that I want to mention before I actually turn the transmitter on and start reading from it is how to actually connect the transmitter to the receiver. So here I've got the receiver, and these 2 power lines are actually used for something else as well. So I'm going to move these power lines to a different channel entirely. And then if you notice the top channel there where the power normally goes, it says B/VCC. So VCC just stands for power, but the B indicates that's how we can use that channel to bind this to a transmitter. And we do that using this little thing that normally comes with a transmitter and receiver. And what it does is it connects all 3 of those pins together. So I'm going to put this on here like that. And that connects all 3 of those pins together. And so now if I power this thing up, and then on the transmitter, I have this bind key. So I'm going to hold that and turn on the transmitter. And there we go. So it flashed by pretty quick, but it said that it was binding, and then the bind was okay. And so now we are bound to the receiver. All right, I have fixed the power on the receiver back to where it's supposed to be, uploaded the code, which is now running on the Arduino. And so right now the transmitter is turned off, and so when it attempts to try and read from each channel, it's going to read a 0 because it's going to time out. There's nothing there to read. I will use this a bit later to actually detect whether or not the transmitter is turned off or on, because if it's off, I want to throttle how often I'm checking for new signals, just because I don't want to continue, running through the channels to try and read values if the transmitter's off. So I want to throttle that back and check it less often to save some power. So now I'm going to turn the transmitter on, and we will immediately start seeing values get read in, just like that. So now we see all channel values now have a value that is roughly between 1,000 and 2,000. And what this means is it's between 1 microsecond and 2 microseconds. So now what we can do is we can look at the individual channels and see how the controls actually modify them. So for channel 1, which is the horizontal on this stick, if I push it to the right, we see that value start to go up just about to 2,000. And then if I push it to the left, it goes down to just about 1,000. Same thing for channel 2. If we go up, it goes up. And if it goes down, it goes down. Now channel 3 is a little different because of the fact that since this is typically the throttle, it starts in the low position here, and it doesn't have that sort of spring back to the center like this stick does. So it starts at near 1,000, and then as I push it up, it actually will stay where I put it. And so, but it then goes up to 2,000. So the entire range is the same, but it just doesn't stay at the middle like the other stick does. So it actually starts at the bottom. So we'll have to do a little bit of extra coding to sort of account for that. Now, if we go left and right, though, it does the same thing. It goes from just about 1,000 up to 2,000. Now, the knobs are kind of like channel 3 in that they start from 1,000, and then as I turn it, those values go up to 2,000 and then back. And then same for channel 6, goes up to near 2,000 and then comes back. So the next thing that we actually need to do is get this a little closer to the actual range that we want it to, which is exactly 1,000 to exactly 2,000.
And there we go. Now we know what the range of values looks like for each channel from the transmitter. So the next step is going to be taking those values and actually constraining them to a specific range, to exactly 1,000 to exactly 2,000 with nothing outside of that, and then mapping each of those values in between to an output value that's within 0 to 256, so that we can use that with pulse width modulation for output to the LEDs. With that, if you haven't seen how we got to this point, I would encourage you to check out the playlist that has all of the other videos that led up to this point. If you like this video, leave me a like, and if you want to see where all of this is ultimately going, hit that subscribe button. Thank you so much for watching, and I'll see you next time.